This article was published in September 2024, and it's titled Structuring the Audit Objective, 10 Key Aspects of Algorithm Integrity. So the background to this is that in episode 1, in that article, we explored the challenges of placing undue reliance on audits, and this is an attempt to simplify that and breaking it down into a set of key areas to consider as you define that scope and put together that audit objective. So here we go. Structuring the audit objective, 10 key aspects of algorithm integrity. In a previous article, episode 1 that is, we explored the challenges of placing undue reliance on audits. One potential solution that we outlined is a clear scope, particularly regarding the audit objective. In this article, this episode, we will focus on algorithm integrity as the broad audit objective. While it's easy to assert that an algorithm has integrity, confirming this assertion is a bit more complex. To help simplify that, we'll break it down into a set of key areas to consider. Mixing and matching the various aspects could help shape an ongoing audit program that works for your specific context, objective, and needs. 10 key aspects of algorithm integrity. These are not ranked and do not appear in any particular order. Relevance and importance will vary based on your context. The goal here is to provide clarity on what algorithm integrity can entail as you plan your audit program. It is important to note that this list that I'll read out in a sec is not exhaustive. It was designed with banking and insurance algorithms in mind. Importantly, it focuses on traditional algorithms. So examples of those would be traditional machine learning models like linear regression or decision trees, and rules-based systems or rules-based models. And just as importantly, it is not tailored for emerging AI systems or models. So it's not for generative AI or LLMs, large language models. Emerging AI systems are often complex, opaque, and present a unique set of challenges and considerations. While the items that I will read out may apply to them, the nature of these systems and the context in which they are used means that other aspects may be more important. In addition to that, some of the detail will be very different. So for example, when we talk about accuracy and robustness, which is the first aspect, determining the accuracy and robustness of a large language model is not the same as determining the accuracy and robustness of a traditional model. With that context established, here are the 10 key aspects. Number 1, accuracy and robustness. Number 2, alignment with objectives. Number 3, fairness, including impact assessments. Number 4, transparency and explainability. 5, security. 6, privacy or privacy. 7, governance, accountability, and auditability. 8, risk management. 9, ethics and training. 10, compliance. And there's a table in the article that I'll try to repeat in an audio version. It may not go exactly as planned, but let's give it a go. And that table expands on each aspect broadly. So the first aspect was accuracy and robustness, and the description of this is that outputs or results are correct and align with expected or true values. The algorithm performs consistently and dependably under various conditions, including edge cases and unexpected inputs. Feedback loops and performance metrics to ensure ongoing accuracy, robustness, and reliability. When we talk about accuracy here, we use it as a blanket term that includes completeness and validity where those concepts are relevant. So it's not quite the same as accuracy would be defined in a financial audit assertion context. We are just including completeness and validity there under the banner of accuracy and robustness. So the second we spoke about was alignment with objectives. And this means that the algorithm or algorithmic system serves its intended purpose and it aligns with organizational goals. Number 3 is fairness, including impact assessments. So here what we mean is biases are mitigated especially as they relate to protected attributes. And there's a link to another article where protected attributes are discussed, and we'll try to put that into audio version shortly. The design ensures equitable treatment. Data is not used unless specifically needed and does not introduce bias. External data is not used unless specifically needed and does not introduce bias. Of course, this is similar to the previous point, but it is important enough to repeat. We've seen several situations now where external data is just thrown in. And then lastly, for this item, the potential impacts on individuals, groups, and to an extent society are assessed using representative data. Number 4 is transparency and explainability. And simply this means understandable and interpretable processes and decisions. And this includes clarity about data sources, quality, and decision-making logic. And this sounds quite short, and it actually is quite short. But what this means is that you can explain how a decision was made. It's not just a black box. The 5th item was security. So this is protecting the algorithm, including its design, its data, and infrastructure from unauthorized access, manipulation, or exploitation. And then the corollary to that is ensure that authorized access is provisioned. And we give a link to an article where that is explained a little bit. And then incident response and recovery. So an example of this would be fallback processes. The 6th category is privacy. Privacy. This is about safeguarding personal data, ensuring compliance with privacy regulations, maintaining data confidentiality throughout processing and storage. Number 7, governance, accountability, and auditability. So here we want to establish clear lines of responsibility for the algorithmic system and the resultant decisions. And this will include things like ethical oversight, data governance, oversight of the development of the algorithm, and then its deployment and operation, among various other factors. We document the algorithmic system, including risks, controls, testing, processes, decisions, and performance over time, and then enable independent verification and review through documentation and audit trails, and that's systematic record keeping. Number 8 is risk management. Identify and manage algorithmic, ethical, third-party, that's vendor, and other risks throughout the system lifecycle, making sure to monitor and adjust risk mitigation strategies on an ongoing basis. Number 9 is ethics and training. So this is about establishing ethical oversight and frameworks for decision making in relation to how the algorithm will be constructed, largely. Identify, assess, and manage ethical risks. Document relevant codes of conduct, policies, and guidelines. And then conduct ethics training, including bias awareness. Number 10 is compliance. So this is adhering to relevant laws and regulations, adhering to contractual obligations, possibly considering industry standards, and all of this while maintaining documentation of compliance efforts and staying updated with regard to regulatory changes. Those are the 10 items. It's a bit of a mouthful, but easier potentially to read, so I'll put a link to the actual article in the show notes. And so then we ask the question, is this not too much for one audit? And sometimes it can be. If it's the first audit that you're doing, or if your overall objective is something other than certification or compliance, and that's an important point. Now, if you're doing the audit for compliance or you're doing the audit for some form of certification, you're probably going to want to just do all of them. You're probably going to need to do all of them. But let's assume this is either your first audit or your overall objective is something else. If it's not practical to cover all 10 in one go, you may be able to split it into bite-sized chunks. Instead of including all 10 aspects in every audit, one potential approach is to separate the items into 3 sets. The first of those are the areas that you'll cover each time. So these are the critical aspects. You want to make sure that you're covering them as part of audits every single time. I won't tell you exactly what those are because that will vary depending on your context or circumstance. But if you're doing a bias audit, for example, if you want to know that there's no bias, you're obviously going to look at fairness every time. Then there's other areas that could be rotated. So covered in every alternate audit, for example, where you have low risk items with infrequent change. So let's say your policies don't change, or your policies change every 2 years, and you know that there aren't any changes that are happening. You may not want to, and you're doing audits every 6 months. You're not going to look at policies necessarily every 6 months. That's just an example. I'm not saying that that's something you must exclude, but that's just a really easy, simple to understand example. And then there'll be some areas that rely on other audits. So examples of this might be security and privacy that have broader dedicated reviews. Quick note here is reliance requires some work. So it doesn't just mean you can say, it's over there, I'm going to leave it alone. You typically want to understand the specifics. So that means consider your unique risks in the area. So what privacy, for example, may mean for your model, and then cross-reference that to what has already been covered in the other review that you're placing reliance on. This splitting, separating approach allows for thoroughness over time without overwhelming your team. The specific frequency of your audits may vary. This can depend on a range of factors. So, for example, process changes, model changes, etc. And hopefully in a future article, we'll delve into some audit frequency guidelines. Overall, scoping is important, but it does not have to be difficult. And this list should hopefully help with your scoping exercise. Consider how these aspects relate to your context, your objective, and the needs that you have for your audit. Importantly, write it all down to ensure clarity. It is good practice when commissioning an audit to write it down, and you won't regret spending the time and effort. I can't finish here without talking about what this article is not. And so a quick disclaimer. So the information in this article does not constitute legal advice. It may not be relevant to your circumstances. It is certainly not appropriate for high-risk use cases as outlined, for example, in the Artificial Intelligence Act, Regulation EU 2024-1689, also known as the EU AI Act. It was written for consideration in certain algorithmic contexts within banks and insurance companies. It may not apply to other contexts, and it may not be relevant to other types of organizations. Thanks for listening.